Yeah, drop, hey, huh.
Yo, what's up everyone, this is 𝗪𝗏𝗟𝗟𝗟 and today we're gonna solve the Quack Quack Pawn challenge from Hack the Box. So we go here and we download our file. It's here, we unzip it with password hackthebox, and then we see there is a challenge folder with a dummy flag inside and our binary, Quack the duck, Pepe. Where are your quack manners? Okay, we cannot get much from the interface. So we open the program in a disassembler of our choice. I'll go with Binary Ninja this time. And here we see the main function. Okay, it doesn't do much. So we go to the duckling function here. And we see that it sets up our buff1 with 0x70 bytes of allocated space, and we read up to 0x66, so there is no buffer overflow here. And after that it does an str in our buffer, and it searches for the quack quack space string. If it does not find it, it exits with where are your quack manners, the message that we saw. Otherwise it prints quack quack %s from the offset that it found the quack quack space string here up to 0x20 bytes. So it will leak this address to us. Okay, generous program. And after that there is a buffer here, buffer2, and we read up to 0x6a bytes to it, which will probably lead to a buffer overflow. But first let's take a look at the binary. 64-bit executable, dynamically linked, alright. And inside the debugger we're gonna run its exec and see that it has canary and there's no pi, thank god, and it's linked to this libc. Alright. So what can we do with that? If we fuzz around the program, we can see that there is another interesting custom function, this one here, duck attack, which opens the flag for us. So this is our main goal. But in order to call that as a simple red to win challenge, we first need to leak the canary. Otherwise the program will hang and we cannot proceed. So how will we do that? Let's go back to duckling here, so we have a visual. And let's start with breaking in main. We run the program. Okay, here we see there is a call to duckling as expected. Let's step in here. Alright. And we see that it allocates 0x80 bytes for our buffer, even though here we saw 0x70. And we continue, and after that is the quack the duck, as we see here, quack the duck, and then a flash, and it's time to read. So in order for the program to not crash, we need to include this quack quack space, but for the time being we won't do that. We're just gonna go with 4 A's, 4 B's, 4 C's, 3 Ds and a new line, and we see that it's stored at this address, and we're gonna go with x20gx_rsy, and we see that this is the start of our buffer, and this is our A's, our B, C, D and the new line. So we start writing from here, and this is 8 bytes and another 8 bytes, so the whole line is 0x10, so we have 10, 20, 30, 40, 50, 60, 70 and 80 here, where this value seems a bit interesting because if you see it ends with 2 zeros, it's a whole address. And if we take a look at the canary, we see that it is exactly this. it's the same value, and it says that yeah, this is the same value. So the good thing here is we know where we write, and we know where the canary is, and we also here we have a nice link 0x20 from where it found the quack quack space. So imagine we fill this and this and this and this and this and this. If here we have the quack quack space, it's gonna go, okay, now I need to lick from here that I found the quack quack string up to 0x20. So here 0x10 and here 0x20. So it's gonna lick this address to us. So as I said, it's 10, 20, 30, 40, 50, 60. So let's say 59 and a new line. So let's go with that. Let's proceed with our solver in the time being. So we go here. Yeah, I will rewrite that. So let's gonna take my template. What? Okay, so we're gonna go with my template here. As an F name, we're gonna use the quack binary. Here we want it as true for the time being. So this one, when it's true, it's gonna open a local process, otherwise it will go to a remote instance. So here libc, it's not libc related, so I'm gonna remove this line, remove this line, remove this line, and okay, we're gonna need this. Here we analyze the binary, and I'm gonna probably remove this, and yeah, let's just remove all of them. Okay, so what do we need first? We need to pass the first quack quack and send line after this, and we need to send, let's say, A's times 0x59, because we're gonna send line after here, so it's gonna add another 1 byte, and then we need to send the quack space string, and then let's do a print rl, and let's see what this is gonna give us. So we run our solver, and yeah, okay, let's go again. Okay, nice, we see a nice leak here, we don't know what this is yet, so let's go again and let's rec until quack space, which is our payload, and then print the rest. And what we see now, okay, a disgusting leak, but okay, we're gonna work with that. So from that, what can we do? So let's say, let's receive 7 bytes from that, and then are just 8 bytes here, and let's see what we get. Okay, we see the null byte here, which we want because it's a canary, and let's try and make it cleaner with 𝗧64. Alright, and let's add this as our canary here, and print canary, and we have the canary value here. So let's see if this gives us what we want. Python solver. Alright, this looks like a good canary to me. Nice and clean. So this way we licked our canary, and after that we're gonna head back, now that we have our canary, and see at which offset we have the overflow. So let's go again, 𝗪𝗪𝗥 run. So we are inside duckling, we proceed, and at first read, in order to bypass the check, we're gonna use quack quack space here. So okay, good, it will pass the check, and then quack quack, ready to fight the duck. So another read function here. So we're gonna go with A, B, C, D, and new line, and again we're gonna check the RSI here, XGX RSI, yeah, nice. And we see here we have this, which is 0x10, 20, 30, 40, 50, 58, and at 60 we need to override the canary, and after that it's the return address here. So it's 10, 20, 30, 40, 50, 58, and after 58 we override the canary. So let's go. Send line after, I guess it was again this, and we have, and it was rox58 I think, plus p64 the canary value, and then we override the return address. So I guess this should be p64 and e.sim.duck_attack, which prints the flag here. Yeah, duck attack. So after that let's go with r.interactive and see what we've got. If our calculation were correct, we should get the flag. I messed up with something, but where did I mess up? So duckling here, the string is quack quack, ready to fight the duck, and it has this, so this one is correct. Send line after this is okay. I don't know where we messed up, but let's try 60 here. I don't know if I messed up with counting. Smash tag detected, so no, this was correct. The canary here was correct. 58. So it probably needs a stack alignment. So I'm gonna go with the wet hands here and see where it gets me. Oops! And we got the flag here, nice and clean. So if we wanna test this remotely. We just go here, we start an instance, and we change this to false, exit, and we do solver. Okay. And this way we get the flag here. So thank you guys for watching. See you on the next video.